Alright, we're here today in my closet talking about glow-in-the-dark protons and how they're charged by different light waves. So we got the red light here, which has a big wavelength, but the density of the particles within that wave are low, so it won't charge the protons in here as much as different colors. Put the ball on the thing for a bit, and as you can see, nothing's happened. It's not charged because it's such a low particle density within the wave. But if we change the color to something brighter like blue, which has a smaller wavelength but more particles within that wave to make it more dense, it should charge us up more. And see, all those protons built within the material, the glow-in-the-dark material, have been raised up and have held the light from the blue light thing bulb. Now it's glowing and retaining that and re-emitting it until the protons slowly go down and it'll be back to normal.
It looks really cool.
Wow. This concludes the experiment with light waves. Whoa, yeah! We're gonna be demonstrating how light interacts with different mediums. What do you think a laser is going to do whenever it interacts with a solid?
Solid, it would just hit it. It wouldn't like reflect or go straight through it.
My hand is a solid.
Duh.
And this is a laser. Oh, it's stopping on my hand because my hand's solid. What do you think the laser is going to do whenever it interacts with the water?
Go straight through it.
Because it's going straight through. This concludes the light part, the light waves.
What is a wave? A wave is a disturbance of a medium which transports energy through the medium without permanently transporting matter. In a wave, particles of the medium are temporarily displaced and then return to their original position. There are a variety of ways to categorize waves. In a transverse wave, particles of the medium are displaced in a direction perpendicular to the direction of an energy transport. In a longitudinal wave, particles of the medium are displaced in a direction parallel to energy transport. Another way to classify waves is whether or not the wave requires a medium. Mechanical versus non-mechanical. Mechanical waves are waves that require a medium for the transfer of their energy to occur. Water waves are an example of mechanical waves. Tsunami waves are released after an earthquake transfers the energy of the quake to distant shorelines. Sound waves are another type of mechanical wave. A medium is defined as the matter or stuff through which the wave travels. Non-mechanical waves are waves that do not require a medium for the transfer of their energy to occur. Electromagnetic waves are the only type of non-mechanical waves. They can travel through the vacuum of space or they can travel through a medium. Light from distant stars travels hundreds of thousands of millions of years to reach us. Although the electromagnetic radiation spans a large spectrum of wavelengths and frequencies, all electromagnetic radiation travels through a vacuum at 3.00 x 10^8 meters per second, or c, the speed of light. EM waves travel slightly slower through air at 2.97 times 10^8 millimeters a second. The medium of a wave is a matter through which a wave travels. The medium is matter in the solid, liquid, gas, or plasma state. There's solid, liquid, gas, plasma. The last slide shows the anatomy of the wave. A transverse wave is a wave in which the particles of the medium are displaced in a direction perpendicular to the direction of energy transport. A transverse wave can be created in a rope if the rope is stretched out horizontally and the end is vibrated back and forth in a vertical direction. If a snapshot of such a transverse wave could be taken so as to freeze the shape of the rope in time, then it would look like the following diagram. Particles of the rope are moving up and down, energy direction, then the energy of the wave is moving from right to left.